Jai Hind, everyone. So, welcome to the chemistry class. In last day, we have discussed about that different properties of the matter, and lastly, we have talked about the Brownian motion. I think so. From today's class, we have start with the different states of matter. Okay, so let's start our today's topic. So first of all, already we know that there are three different states are present in generally I am talking about solid, liquid and gas. So for when we talk about these properties, we have to know their different properties. So if I talk about the solid, what are the properties? Solid has a fixed volume and the definite shape. Solid has fixed volume and definite shape. The first point is really mentioned very well. The second point is the solids are very rigid and almost incompressible. We cannot compress the solids. Solid may break under force, but it is difficult to change their shape. Solid generally possess high density. Solids do not exhibit diffusion. In solid, intermolecular force of attraction is stronger. So this is a very important point, and that is why its density is high. It is generally it is not so. It is highly incompressible in nature because force of attraction is strong here. So one important aspect we are getting here, that what is density. It's coming here that as I told about that solid has a great the high density. That what is density? Density is nothing. The mass of a substance per unit volume is known as density. So in your left corner, the definition of density has been given. The mass of a substance per unit volume is called density. So if I am writing like this, the density equals to mass per unit volume. Mass per unit volume. Like these numerals we can explore like this. Next one, if I am asking that, okay, what is the unit of density? So you can easily say that, okay, unit of mass divided by unit of volume. So it will be the kg per meter cube. It will be the kg per meter cube. So this is the first point. You can easily remember the point one also there, that example of solid state. So I don't think that we have to mention the example. Everything I can see that these are solid. Like if I talk about that these mobile or these books, chalks, duster, even me also the solids. Okay, so these things you have to remember. Now we are moving to the next part, that a one very important point I think. See that in your the assignment also this type of question is there. Why a wooden block should be called a solid, or a rubber band is called a solid? So here they have good, very well explained the answer here, that a wooden block we are talking it is a solid. Why? Because it has a fixed shape, it has rigid, it has a volume, a fixed volume. That is why it is called solid. So the properties you have to say. Now next one, if I talk about that a rubber band is stretchable, obviously then why we are calling it as a solid? Rubber band is a solid because you know that it undergoes change its shape on stretching. When obviously if you remove the force, it will remain its own shape. That is why it is not, it is changing on its shape on the outside force. So that is why they are known as the solid. Now one very point, the point was they are solid generally do not exhibit diffusion. So as you know that they don't have they are very, they are highly attracted to each other, and that is why the diffusion is very less here. So I am not explaining these things again. So we are moving to the next part, that liquid state. Liquid state is a very important, that liquid has a fixed volume, definite volume, but it doesn't have any shape. Obviously whenever you will put it obviously it takes itself according to its container. So it's a very important lesson is also that you have to adjust, you have to make yourself comfortable in every places. Sometime it will be that like jar place, like it sometime it could be a only normal bottle. So you have to take your shape on the basis of the container. So it is a very important, from the nature you can learn these things. Now coming back to the point, that as I told about that liquid I'm asking talking about the different properties as well. So before moving to the different properties, one important aspect I have to share with you, that when I talk about the volume, so remember that the volume, the shape occupied by a liquid substance is called volume. So definition of volume we are getting now. What is the SI unit of volume? SI unit of volume is a cubic meter or meter cube. Here it is mentioned that meter cube, but generally we are using the different unit, common unit, that is called liter. In generally we are using the liter unit, we are not using generally the meter cube unit. Now unit conversion is a very important thing which you have to know, that when I talk about the 1 meter cube equivalents to 1,000 liter, or equivalents to 1000 decimeter cube. That means that 1 liter equals to 1 decimeter cube, 1 liter equals to 1000 milliliter, which is equivalent to the 1000 centimeter cube. So these important points you have to note down, because these are the very important point. It will be required when you are doing the numerical problem. Suppose one MCQ question is there, you have to practice this. Okay. Now, as I told you that properties of solid is a liquid is important. As we talk about the solid, again we are moving back to the liquid. So liquid, obviously liquid have the definite volume, but it does not have the definite shape. Liquid are almost incompressible, but they are not rigid. They are flowing. Okay, they are that is why they are called fluid. They have the property fluidity. Solid doesn't have the fluidity property. That is important. Liquid can undergo diffusion. We know very well that liquid show the diffusion properties. If you take one drop of ink to the one glass of water, you can see that the diffusion happen, the solution will be color. So that is that liquids can undergo diffusion. Now liquid have the high density, but obviously it is a less than solid, because the intermolecular forces is a less here and interparticle space is more here. So this 2 point is important, which is not present here, that intermolecular forces attraction are weaker than solid, but intermolecular space is larger here. So these points you have to remember, that like liquid gases, or the like gas, liquid can also be diffused. So one point I am telling here. Now next point I am going to, that the gases also diffuse into liquid. Very important examples I am giving you, that the gases from the atmosphere diffuses and dissolve it or water respectively. Now specifically that all the aquatic animals survive in the water. Now we know everyone that we need oxygen. So from where they are getting the oxygen? Those who are present in the inside the water, they are capturing the oxygen which is already dissolved in the water. So we are getting an idea that gas molecule can also be diffused into the liquid. It is a one thing. Also one very important aspect is that you have seen that we are drinking, we are liking to drink the soft drinks, cold drinks. You can see that whenever you are open the bottles, that the gas is coming up, that the dissolved carbon dioxide is then present there. So we can, from this aspect you can get an idea that gas can also be diffused in the liquid. So it is a very important point. Now we are coming back to the gas is the one very important thing, that it it doesn't have any shape, it doesn't have any volume, and it is highly compressible in nature. Suppose we have known about our LPG, that cooking gas cylinder, the LPG we are generally using. So that is a generally 15 liter 14 kg cylinder is there, right? In the 14 kg cylinder you can see the gas molecule is a large, and when we are by giving the pressure, in the high pressure we are just making it a liquid state, and it's highly compressible. When you just open the knob, the gas is coming up, and we just use this gas as in our cooking, as a cooking gas. Okay, so this is the point was there. Now one important point I am asking you, that everyone knows about the two important natural the gases. One is the LPG, another one is the CNG, and I hope everyone knows the full form of it. If you don't know, then already it has been given there, that CNG means compressed natural gas and LPG means liquefied petroleum gas. I am not writing the full form, because I hope everyone knows about that. But the properties of gas is important here. Oxygen cylinder also, you can say, in the oxygen cylinder the gases is compressed in the cylinder. Property of gas is that property is the first point you can write, that it doesn't have the definite volume, it never has the definite shape, gases are highly compressible. The second point you can easily idea that, and also the gases exhibit the property of diffusion very fast. That means the diffusion is showing in the gas is very far. Suppose you are using the deodorant or say the perfume, we are getting that smell from very far away. What does it mean? That gas molecules are generally spreading, or you can say they are diffused, and that is why we are getting the smell. So the diffusion is a very important property of gas. Intermolecular force of attraction is a very less in gas, whereas the intermolecular the gaps, or you can the intermolecular spaces are very large over here. So if I am just taking an example, the simple thing, that few examples are there, that due to which has happened because of the diffusion property of gas, and we are the application is a very good here. So first one already I'm telling about the smell of perfume we are getting from a very much distance. Also you can get that if you have a smell of, you get the smell of a hot sizzling food reaches us several meters away, but the smell of cold food we are not getting. So these things are there, we have to read this one. Now next part is there, what is pressure. One more important property I have to tell you, that gases molecule are randomly moving here and there. Suppose I have keep the gas in a container. I have moving the gas in a container. We know that gas molecule are continuously moving here and there. Gas molecule are moving continuously here and there like this. So obviously when they are moving here and there, they strike the wall of the container, and due to the strike, obviously the force exerted over the by the gas over the that wall, and the force exerted per unit area is known as the pressure. The force exerted per unit area is known as the pressure. So we are getting an idea that, obviously always remember, the sea level pressure is really known as the 1 atmosphere, and which is our normal atmospheric pressure, which is normal atmospheric pressure. Now coming back to the point, that atmosphere is generally we are using for the pressure unit of pressure, but also we are using the bar unit and also the Pascal unit. We know that SI unit of pressure is Pascal. SI unit of pressure is Pascal. P for Pascal, just remember that PASCAL, Pascal. Who knows? Give that Pascal law. So PA. So this is the unit of pressure. Now those which is a common unit we are using here. Number one, it is the atmosphere unit we are generally using, and the bar unit generally we are using. Sometimes also we are using the Pascal unit. So unit conversion is generally given there, that 1 bar equals to 10 to the power 5 pascals, 1 bar equals to 1.01 atmosphere, and 1 atmosphere equals to 10.1 into 10 to the 5 pascals. So these unit conversion you can write it one place, so you can, if sometimes you can just check this one, you can get an idea that okay, what is the relationship between the atmosphere and Pascal, or bar and Pascal. So I hope you get a little bit the idea of the pressure here. Now if I talk about the example of gas assisted, I should not tell about you, because everyone knows that air itself is a gas. Hydrogen, carbon dioxide, hydrogen sulfide, lot of gases are there. So these are the example of gases. Now the one question is there, it is very good questions. I hope you have also seen this question. We can easily move our hand in air like this, but we cannot move this air through the solid. Obviously we have to be a karate expert, we have to be Bruce Lee. But why, what is the reason? So you can just remember here, the just see that that answer is given like a huge thing. Simple things you have to remember, that interparticle force is strong in, very strong in the that solid phase, whereas the interparticle, if the interparticle attractive force is very less in the gas, and that is why we can easily move our hand. But when I talk about the that solid particle, the attractive force are strong over here, that is why we cannot move our hand easily. So that is the we have to be a karate expert. So this is the example, you can give the example like this one. Obviously in the answer it is been given a longer way, but you can easily make it as a switch shorter one. Now we are moving to the next two different state. One is called plasma state, another called the Bose-Einstein condensate. In last class, I also mentioned you that two type of state are generally present. Number one is the plasma, number two the Bose-Einstein condensate. Though both are known as the fourth and fifth state of matter, but they are generally present in extreme condition. They are not generally present in normal condition. If I talk about the plasma, plasma is nothing but a gaseous free ions, gaseous which is made is from the free electrons and ion. If I talk about that, you know that the that sun has the plasma. It is just showing that the plasma picture of picture of the sun I can think. Okay, so the color is coming here, the ion is there, the gas is high in high temperature, even in the million of temperature is there, and on that temperature the everything will be form an ion, and that state is known as that plasma state. So plasma state also doesn't have the definite shape and definite volume, so we are not talking about these things. Generally they are present as electrical neutral medium. Okay, because positive and negative particles generally is present there. All the natural stars, the stars are generally has the plasma state because they has a high temperature. So I talk about the sun here, so you are getting an idea of the plasma. Now if I move into the next part, that Bose-Einstein condensate, obviously from the name you are getting an idea that fifth state of matter, the concept has been given by the Satyendranath Bose and Albert Einstein. I hope everyone knows about these two brilliant scientists. Here is the picture of these two scientists who gives the theoretical aspect of the Bose-Einstein condensate. They give the idea that okay, that one fifth states of matter is present there, and you know that they have given physically this concept, and 50 years it took the scientists to 50 years to actually convert this Bose-Einstein concept, the condensate, as a practical reality, and it made by the three scientists, that Cornwell, Cattrall, and Wieman, who made that the from the rubidium 3137, they made the Bose-Einstein condensate. They get the existence of Bose-Einstein condensate, and on that basis they got the Nobel Prize. They won the Nobel Prize in physics in 2001. So this information you should know, and it's a very important. Now we can ask me, sir, how the fifth state of matter is generally looking like this. So first of all, I should say you, I, I shall, I, I have to tell you that we are making, obviously the condensate has been made, but it has not any practical use, because we cannot see that fifth state of matter. It is very small. That theory we can explain in the quantum theory specific. Okay, that is important that example, but in our practical life we cannot show the applications. Scientific, it is a scientific discovery, it has practical exam, but in other field, okay, we cannot see normal field like solid, liquid, gas we are looking at. Okay, so these things we are talking about. So one question is there any similarity in materials? So remember that yes, there is similarity between the materials, because they are all made up of metals, and they looks like there's liquid, gas, and solid. They all occupy space and have mass. So up to this one today I am talking about. Again we'll start the next page. Till then, take care. Goodbye. Jai Hind.